Uh, Hi, I hope I'm audible. Uh, yeah. Hey, can you guys hear me? Okay. Let me just um share my screen. Okay, so hello guys, welcome to the session. Today we'll just go through all the important concepts. Okay. Um, and yeah, let's just get started. So we will be covering all of these topics today. Um, and Legend will be starting with the first topic.
All right, so the first topic is quadratics. Is there like anything specific you all want in quadratics? Like, do you all want any questions to be solved? Because like overall, it's quite an easy topic. So like there are just certain ways to certain methods you use to solve them, which are completing the square and the quadratic formula. So if there is anything specific you all want, I can help with that.
Oh yeah, I think you can just go through the syllabus points and then we can move on. I guess.
So like I can give some basic points. So if you use completing the square method and like if you have to find the minimum point of a curve, you can use the completing the square method and you'll get it as x minus a whole square plus b or minus b, whichever is the case. And your minimum point would basically be plus a comma uh, sorry minus a comma b, whatever. Like if you get the completing the square value as x minus 2 whole square plus 13, so your minimum point would be 2 comma 13, because it's basically you find the the power value is 0, and after that it's just the plus 13 that remains. So that's one thing. And of course, I think you all would know how to find the factors and intersecting points on the x-axis, y-axis, since this is a re-exam which you all will be giving.
Um, okay, yeah, so we'll move on. Like, most of quadratics is pretty easy. Like, over here, they have basically stated everything that you have to know how to solve quadratics. You also need to know about hidden quadratics. So, there's a bit of that ahead. You have the quadratic formula over here. Make sure that you memorize it properly. In hidden quadratics, you can have something like this. So the highest power could be x raised to 4. The second power could have x squared. That would be a hidden quadratic. So you'd have to substitute it to, for example, x squared is equal to z, for example, and you make a new quadratic. And once you get your values for z, make sure to input them back into the substitution so that you get your values for x. Um Apart from that, the only important thing in quadratics I feel is this part. So like whenever you have to find the intersection between a line and a curve, for example, you start by equating the both the equations, right? And it's basically like a simultaneous equation, which is pretty easy. Now, whatever equation that you get from equating the two functions, basically, that's your equation of intersections in fancy terms. Now, whatever the like the number of solutions that equation has is basically all the number of intersections between the line and the curve. So in that case, you can again use the discriminant to find out what all like how many intersections there are between your line and graph. So it could either be once, it could be twice, or it could be never. And you use the same concept as like how it usually is for discriminant. Like if the discriminant is greater than zero, so in that case there are two distinct intersections and it's basically crossing the x-axis. If the discriminant is zero, so there's only one root, or it's also known as repeated roots, and it touches the x-axis only once.
It's
And
a
if
tangent basically.
basically, yeah, and if it's less than zero, then you'd have no roots. So you can just go through this afterwards. Yeah. So yeah, pretty easy so far. And moving on. So now we come to functions. In functions, you're expected to know the types of functions. So you have one-to-one functions, okay, inverse functions, composite functions. You will be expected to find the range or domain of a given function. Um, so, for example, if you have 1 over x, you need to know about simple rational functions and everything. So, I'll go through all the type of graphs moving on. Also, we'll be sharing the recording for the session if anyone is wondering. Okay, moving on. Then you have to determine whether or not a given function is one to one. Okay, you have to find the inverse of a function. So just keep in mind that usually there's a one marker where they ask you to state whether a function has a inverse function or not. So the condition for a function to have uh, an inverse function is that it must be one to one. So make sure that's the case. After that, you need to know the relation between one-to-one functions and its inverse. So just keep in mind that it's going to be a mirror line. There will be a mirror line of y is equal to x. So the one-to-one function would be a mirror of its inverse across y is equal to x. Then you need to know about basic transformations. Um, so like a horizontal or vertical shift. Then you have vertical or horizontal stretch, and yeah, then you just have mixture of all those combinations. Also make sure you use the correct terms when you're writing all your transformations, like you use translation, reflection, stretch. Okay. um Moving on, so I'll just go through all this quickly because most of you guys already know about this. It's pretty easy so far. So you have a function which is like a mathematical relationship. Then you have types of functions. This is more out of syllabus, but it's best if you know about it. You can have one to many to many, one to one, or many to one. Then domain is basically a set of all the acceptable inputs. Okay. Then you have range, which is all your possible or acceptable outputs for a function. And then depending on how your domain maps onto the range, you can classify each function as one to one, many to one, or one to many. Then yeah, only one to one function can have an inverse function. And then moving on. Um,
So I one second, I'll just
yeah.
wait. So in a quadratic, it's obviously in the beginning a quadratic is not one to one. But if you take the quadratic from the minimum point, and if you take lesser than the minimum point or greater than equal to the minimum point, then then it would be a one to one function because the other half of the quadratic, uh, like the graph, won't be present. So keep that in mind. when solving questions.
Yeah, that's a good point. Just keep that thing in your mind when you're solving. Um, yeah, moving on. Then you have composite functions. This gets a bit tricky sometimes. You basically have this entire thing of checking whether a suitable domain fits the range. Wait, let me just go through all these steps. So to check the range and domain of your composite function, you have to check the inner function first of all. So in this case, you have g h of x. Okay, so you're basically inputting h of x into g of x. That gives you your composite function. So you start with the domain of your inner function, which is h of x, and that's basically all the x values that you're allowed to substitute into h of x. Then you have to check what happens to the input in g of x, because you're basically inputting h of x into g of x, right? So your input for g of x is basically h of x. Now, for each x in that domain, you have to compute h of x. So, in simpler terms, you're inputting the value of h of x. So, the output value of h of x gets inputted into g of x in simple terms. If h of x gives values not allowed in g of x's domain, you have to remove those values. And for determining the domain of your composite function, the domain of g h of x is basically all x in the domain of h of x, for which h of x lies in the domain of g of x. So it's best to visualize this using this map over here. So yeah, that's pretty much it for composite functions. And you have all of these important types of graphs that you need to know about. You can just go through them. A linear function is pretty easy, it's just one to one. Similarly, exponential, you don't need to know much about exponential, but just the basic shape helps. It's one to one as well. Then you have these reciprocal functions like these two over here. Personally, I feel that if you know about them, like you can plot them on Desmos and everything, so that would help you a lot because you get those 2 3 markers where they expect you to state the range or domain of rational functions. So yeah, you can just read through this afterwards. Quadratic is pretty easy as well. Its shape is a parabola. If you want to make it one to one, like Legend said, you just look at the vertex and you use it to determine the new domain to make it one to one. And yeah, cubic is pretty easy as well. So these are all your frequent types of graphs.
And
Uh,
one more point for composite functions. Uh, so it's you like there is gh of x, but it's also possible to ask you gh of x whole inverse, and and you might see that in most of the cases gh of x would be a quadratic. So in those cases, y'all would probably know it, but y'all would have to make it into like create like gh of x in a completing the square, and then only you can take the inverse of it. Yeah.
oh yeah, that's a good point as well. That'll really help you. Okay, then moving on to coordinate geometry.
Yeah, so coordinate geometry. I'll be sticking to A and B as the center. People even use P, Q, or any other letter, whichever is find suitable. I find A and B the best. So you all would know that way this is written, this is basically the equation of a circle, and it's written as x minus a whole square plus y minus b whole square is equal to r square, where if you take a and b, that is the center, and remember that the RHS is r square, so you need to take the root of it to get the radius, and you might even get it in the expanded form, which is written on the right side as x square plus y square plus 2g gx plus 2fy plus c. And it's easy to solve such questions by making it into the equation of x minus a whole square. So I'm sure y'all would find it easy to combine the x square plus 2gx and y square plus 2fy into a into the, the brackets.
Yeah.
The confusing part at times could be what happens to c. So firstly, c is basically r square minus a. C is equal to r square plus a square plus b square, or r square plus g square plus uh, f square. And so that basically is so if you make it into this form, you take the c to the other side. Suppose you have c is equal to 61, and you get you have a is 3, b is 4. So if you have to find the radius, you do 61 minus 9 minus 16, which is 61 minus 25, which is 36. So that r square would be 36, and that will give you a radius as 6. So yeah, I think that's all that's needed for coordinate geometry.
Yeah, we also go through some questions related to coordinate geometry, so we'll go through more in depth with this topic. Moving on. Yeah, then you have circular measures. So, wait, let me just see if I can use my whiteboard a bit. Um, Hold on, give me a minute. Okay, till then, let me just explain this part. Uh, right, so first of all, you need to know about the definition of a radian. Okay, so radian is basically a sort of a ratio between your arc length and the radius. So you can actually derive the definition of a radian using this formula over here, which is S is equal to r theta. So S is basically your arc length of the circle, and then r is the radius of your circle, and theta is the angle formed in that circle, right? Or the angle formed in a sector. So if you divide this thing by r, you basically get theta is s over r. And the just keep in mind that for circular measure, the unit of these two formulas would always be in radians. So always double check that your unit is in radians. Um, yeah, apart from this, you have your second formula, which is a is half r squared theta. Okay. Now let me see if I can switch to my whiteboard a bit. Okay. Yes. Um, so for circular measure, another thing I want to add on is that make sure you know the following formulas. So your first formula that you should know is cosine rule. Okay, wait. Let me use a better pen. Sure. Yes. So for cosine rule, uh, because most people tend to forget this, it's basically c square is a square plus b square minus 2ab cosine c. Um, just to give a better idea, if you were to make a triangle, okay, this is a capital C by the way, and these letters over here are in lowercase. So let's say you have lowercase a, lowercase b, and lowercase c. So the angle which is opposite to the side C is your angle C, or capital C basically. You can't really make the distinction, but yeah, I hope you guys get it. And similarly, this is lowercase a, no, sorry, uppercase a. This is lowercase uppercase b again. Sorry. So the thing is, for cosine rule, if you have three sides.
Guidro, I'm not sure if your whiteboard is visible.
Oh wait, hold on. My bad, I forgot to switch. Oh yeah, let me know if it's visible now.
Yeah, yeah, it is.
Okay. Yeah, so basically these three letters over here are in lowercase. So this is lowercase c square is equal to lowercase a square plus lowercase b square minus 2ab cosine of capital C. And if you have three sides and then one angle, you basically make use of this, which is important for circular measure. Another thing which is basically from extended math is that sine c over c is sine a over a, for example. Um, yeah, apart from this, also make sure that you know about the fact that area of a triangle is just half AB sine c, where AB are two sides and C is the angle between A and B. Yeah, and so for circular measure, just make sure you understand the question properly. Um, and yeah, it's pretty easy as long as you know what to do. It's best if you know the formulas and yeah, just use a proper method to go about with it. Okay, now let me switch my screen again. Okay. Um, Wait, is my screen visible?
Yeah, yeah, the presentation is
Okay.
visible.
Now moving on.
All right, so trigonometry, few basic uh, things which are known. Sine square theta plus cos square theta is 1. Sine theta by cos theta is tan theta. I am really not sure which one comes in P1 and P3, but if you have cos theta by sine theta, then there is cot theta. Then you have 1 by sine theta is equal to cosec theta, and though I don't think that comes for paper
Yeah.
one. Yeah, and then there is the quadratics of uh, trigonometry. So one of the examples as shown on the slide, that's 3 sine square theta minus 5 cos square theta minus 1. Obviously, since sine square theta can be changed into the form for cos square theta, because sine square theta is equal to 1 minus cos square theta, you substitute that and you have a quadratic in terms of cos theta. And then it's up, there are two ways you could do it. You could do it normally, or you could substitute cos theta as equal to x, and then again change it back to cos theta is equal to whatever value you get afterwards. Uh, Both the methods work. I I prefer like I don't substitute, or I didn't substitute, and then yeah, I think that's all that's there for trigonometry. There is the proving part of showing LHS is equal to RHS, which is again quite simple. One simple step would be trying to get everything in terms of sine and cos on one side, and that actually makes it very easy to get the RHS. Yeah, I think. Is there anything I'm missing, Gaidro?
Um, like you also have sketching of like
Yeah.
transforms. So
Uh, for sketching, you could just use the calci and get the table function to get the values on certain points. And since it's a sketch, it doesn't have to be very accurate, but it should match the shape. And one important point, so if suppose the sketch is 0 to 360 degrees, and after 360, it is supposed to turn like it is three at 360, it's at its maximum point. Ensure that it doesn't look like it's going to go up after 360. Like just I don't know how exactly they want it, but just show a bit extended version and that it's going down so that they don't cut your marks for it. And I am talking about this from my own paper because it had happened to me.
Um, yeah, and apart from that, I think just make sure you know about basic transformations because you might be expected to apply them over here. Like they've shown 3 sine x, 1 minus 2 x. So make sure you know about periods and how they get affected for trig functions. You also have, like, you basically have basic transform graphs. Um, yeah, apart from that, you need to know about finding all the solutions of a simple trig equation. So you can either use ASTC method or you can use the graph method. Personally, I suggest using the graph method, but it's completely up to you. Um, by now, you must know about how to use it. So, yeah, there is no use of really going through the entire thing. But yeah, just make sure you use it properly. And yeah, you have some basic like graphs you need to know about. Sin x is over here. You have your maximas and minimas. You need to know how to sketch this graph and you need to know the critical values. For tan x, again, you need to know all the basically wait, hold on. Yeah, you need to know all the x-intercepts and then the asymptotes. So like from 0 to 360, your x-intercepts are 0, 180, 360. Your asymptotes are 90 and 270, right? Then similarly for cosine x, you need to know how to sketch it. So yeah, you can use Desmos again for this. Um, okay, and then we come to series. So again, series is usually it's scoring, but some people do tend to get stuck in this. So wait, yeah, let me just use these points over here. You need to know about the expansion of a plus b, the whole raised to n. If you guys ever get stuck, um, like over here, you can open up your MF19 because you will be given MF19. So you can use that as a reference. That's one good thing about CIE. Wait, hold on. Yeah, we'll share the recording and PPT for this so you can check it later. So yeah, you have a binomial series over here, and it's like the general expansion, so you can use this. Um, Apart from that, you wait. Let me just switch tabs. Laptop is tweaking again. Great. Hold on, just give me a minute. Um, okay. Okay, yeah, my laptop hates me. I'm sorry. Just give me a minute. Uh, okay, yeah. So I just wanted to mention that you might get those type of questions where they give you a general binomial expansion, right? And then they could say find the term which is independent of x. So for those cases, you're basically expected to use your binomial, like your general binomial theorem, and you have to make use So if you have like 5x plus 6 over x, for example. Hold on, let me just stop streaming. Hmm. Okay, uh, sorry about that. I'm back.
Do you want me to share screen the PPT?
Yeah, actually, could you do that? I think that would be much better.
Yeah, sure.
Thank you. Let me just share the whiteboard till then. I'll,
Yeah.
yeah, that would be better. Thank you. Okay, yeah. So a basic example is if you have 5x plus 6 over x raised to 4 for example, and they ask you to find the term that
Independent
is,
stuff.
yeah, independent of x. So you can kind of tell from this right away that, yeah, it actually will it happen. Let me think. Yeah, it will. So in this you just use the formula NCR. So a raised to r times b raised to n minus r. So in this, you don't really have to use a formula. You can tell that when r is 2, that's when you'll get a term independent of x. But for like more difficult or more complex questions, you basically make an equation. Okay, so you would say that, and you can ignore these coefficients because they don't really matter. You're just looking at the term which is independent of x. So you can say that x raised to r times x raised to minus, oh wait, let me write it as 1 over x, and n is 4, so 4 minus r is basically x raised to 0. Now using power properties and everything, you get x raised to r times x raised to minus 4 minus r is x raised to 0. Now you add this up, so you get x raised to r minus 4 plus r is x raised to 0. And because the bases are the same, you can simply compare the powers and you end up getting 2r minus 4 is 0, and then r is basically 4 by 2, which is 2, like I said. So you can make use of these tricks to sort of save time. Um, yeah, let me stop
Yeah, and
sharing.
this also that also works for if you have one power of square, like if it's ax plus 1 by bx square. Obviously, if you need it to be independent, you need ax to have double the power of 1 by bx square. Then obviously it will be independent. So just see, suppose it's like 6 as the whole power, you would want a to have a power of 4 and b to have a power of 2. So those kind of things make it very easy instead of expanding the whole thing.
Yeah, that saves you a lot of time.
Yeah.
Okay, then moving on, you have APs and GPs. So first of all, you need to recognize what an AP or GP is. So for arithmetic progression, it's in the form a plus n minus 1d. For geometric, it's a times r raised to n minus r. That's the general term of those series. Sorry, progressions. Then you need to know about some formulas. So you have summation of n for both arithmetic and geometric. Uh, if you guys are wondering, if you ever forget the formula for them, you can check MF19 again. Okay. Uh, and yeah, for summation of n, sorry, summation of infinity, sorry, summation to infinity, which is for geometric progressions, that's only possible when it's converging. And for it to converge, the common ratio must be less than 1. So again, you can use MF19 for that as well. And yeah, you use the condition for convergence of GP. Yeah, you can move on.
Next is differentiation.
Yeah.
Uh, so differentiation, I think there is three rules: product, quotient, and what was the third? I don't remember the names.
Yeah, actually for pure one, we just have the power rule, I'm pretty sure. Like, no quotient or.
Oh, okay. Oh, okay. Yeah.
Yeah.
Okay. So only the which one? Product rule or quotient rule? You all would have one of them, right?
Um, I mean, you can use it, but in pure one, we just taught to use power rule. That's all.
Ah, okay. Okay. Yeah. So obviously you would know that if you have y is equal to x, the derivative is sorry, if you have x raised to n, the derivative is n times x raised to n minus 1. That is the simple thing. And if it's just x, then the constant is what remains. Like if it's y is equal to x, the derivative is 1. If it's 2x, 2, and that way. Uh, and there is you can use differentiation to find the gradient at certain points. So if because it's a quadratic or a cubic, no, I don't think you'll get cubic. A quadratic. The change in the y values between 2 points wouldn't be the same. Like in a if it's a linear equation, the change, like it would be one at x is 1, y is 3, x is 2, y is 5. There would be a continuous change of 2, while for a quadratic that won't be true. It could either increase in change or decrease the amount of change. So you need to find the derivative for it, and you can find the gradient at the certain point, and that you can do so. Like you can use y minus y1 is equal to m times x minus x1 for that, which would give you the equation of a line also, which at that certain point. Like, wait, Gadro, do you all get such questions? I
Wait,
actually don't remember.
could you repeat once?
Do you all get questions like at this point, what is the find the equation of the tangent
Yeah,
at
you could get questions like that. They just expect you to like differentiate and then use the linear equation formula, right?
yeah,
It's possible.
yeah, so yeah, so you all find the derivative and input the x value, you'll get the gradient at that point. And using that, you can even find an equation of the tangent, because you'll have the m value and you'll have x1, y1. You just expand it and it becomes y is equal to mx plus c. And you also have the double derivative, which is used to find the minimum or the maximum point of a quadratic, cubic, or any power for that matter. So I think it's less than zero is the maximum, right, Pedro?
Yeah.
Yeah, if the double derivative is less than zero, it's the maximum point, and if it's greater than zero, then it's the minimum point. Wait, I think you do have product rule. The example which has it has y is equal to 2x cube plus 5, the root of it.
Yeah.
Yeah, so the product rule is there. Okay, so a product rule. What's happening if we are just going through concept errors? Yeah, so product rule. First, the important part is so this the example which is shown, root of 2x cube plus 5, that can be written as 2x cube plus 5 whole raised to half.
So
Equation of circles
you just
is
use power
fine.
rule for this, right?
Yeah, but you use power rule and then you need to find the derivative of 2x cube as well. Like you multiply that as well.
Oh, I think you
That's
mean chain rule because
all right. Yeah, I
yeah,
forget the I
yeah, it's
didn't use the names. Yeah, chain rule. You have to find the derivative of 2x cube as well and then multiply it. So yeah, where should I move on to the last topic?
wait. Apart from that, let me just see because this
Oh,
one
there is a
is.
small changes also. Oh,
Oh yeah, that. If you want, you can. Uh,
okay. Yeah, so the topic of small changes is basically when x changes by a very small amount. So they write it as 2, like they'll give you the value of y at x is equal to 2, and then they'll tell you to find the value at 2 plus h, where h is a very small value. And that basically, uh, you find the gradient at 2, uh, you find the gradient at 2, and like from there on you just see what it would approach ahead. Like I am not really sure how to explain this verbally.
yeah, like basically you just use delta y is equal to m delta x, right? So
Yeah,
change in y is basically going to be equal to the gradient at, like you said, x is equal to 2 times the change in x, which is for example h. So just mh, I guess.
yeah,
uh,
yeah. I
that's
find terms very weird. I don't like.
yeah. Yeah,
But
that's all. Oh wait, that reminds me, what about those rates type of funds where you have to use
rate
um
of change. Oh yeah, dv by dt and
those ones.
yeah. Okay, yeah. So rate of change. Basically, in these kind of questions, there would be volume, radius, and time majorly involved. So maybe they'll give you the volume of a sphere, and you like so you'll have v is equal to what was it, 4 by 3 pi r cubed.
Yeah,
Yeah. So that is your volume. Then you find dv by dr, which is 4 pi r square, and they would give you some rate of change in radius or in the volume. So you would have dv by dt if they will give you the volume is shape given. Not always, yeah. Like they'll give you some change. Basically, they'll give one equation, which if you find the derivative of, you have one derivative, the second one will be given. Like it could either be that the volume changes by 100 cm cube per second, or the radius increases by 5 centimeters per second. So you will have the dr by dt or dv by dt, and they'll ask you to find the third derivative. So you equate it. So you have dv by dr and you have dr by dt. So that has like dv by dr is equal to dv by dt into dt by dr, and you have dv by dr and dr by dt. So you need to find dv by dt, which you just make it the subject,
yeah,
and you will get the answer for it.
yeah, and also just make sure you know the formulas for like volumes of basic shapes like sphere and everything because they won't give you those formulas. So
Yeah,
yeah, that's all for this, I guess. Um,
it's
yeah.
yeah.
Okay, now integration is pretty important. Wait, me. Oh, two people cannot share. Wait, is it? Okay, I'll
Eh,
go through this and then I'll share my screen afterwards. Okay, so first of all, you need to know that integration is basically also known as um, the antiderivative. So it's like the opposite or like the reverse of process of differentiation. It basically undoes everything that differentiation does. So you also need to know how to integrate general terms in the form ax plus b the whole raised to n. So in this case, if you were to integrate it, you'd end up getting ax plus b the whole raised to n plus 1, sorry, divided by n plus 1 times the derivative of the inner function. So just keep in mind that you can only use this for um, cases where the inner function is a linear. So if it was ax squared plus b, then you won't be able to do the method I said you would. So it's just ax plus b, the whole raised to n plus 1 divided by n plus 1 times a. Okay. Then you also need to know about const, constant of integration and everything. So yeah, you need to know how to evaluate that. So like there's an example given over here. You might be given the point 1 comma minus 2, for example. Then you might be given the first derivative. So you would be expected to integrate it first. Then you don't forget to add plus c, because you will lose marks if you don't do that. And then you have to find out plus c using the point given. Um, yeah, after that you need to evaluate definite integrals. So that is pretty easy. You could also have improper integrals where it's like the question examples they have shown you over here. So it's basically the same as integrating. You start by integrating first of all, okay, uh, and after that you input the bounds as you usually do, but in this you sort of like take the limit. So um, wait, let me, yeah, I'll go through the second example after I cover this slide. So after that, you need to use the definite integration to find area of a region and everything. So I'll explain this on the whiteboard as well. Okay, yeah, so then you can stop sharing
Okay.
now. I'll use my whiteboard. I just hope it doesn't lag. Okay, so these are your key points over here. And I'll start with this important example. Let me just, yeah. Okay. So if you are to integrate this thing over here, so this is just the anti-power rule, or you're basically just integrating this. Don't forget to add dx at the end as well. Okay, it's just a good thing if you um, do that. Wait, hold on, my whiteboard. Okay, yeah. So this is. Wait, hold on, my whiteboard is again freezing. Just give me a minute. Sure. Okay, yeah. So this is minus 2 plus 1. So minus 1 divided by minus 1. So this is just uh, minus 1 over x. And then your bounds are infinity and 1. So then you do minus 1 over infinity, this thing, minus minus 1 over 1. So just keep in mind that anything divided by infinity is just, this entire thing is just 0. So you end up getting plus 1 basically. So yeah, just keep in mind, if you divide some number by 0, that gives you infinity. If you do n by infinity, that's 0.
Yeah,
Uh,
so like basically this says that like it won't exactly be zero, it will be very close to zero. So we are basically saying your final answer would be approaching one.
yeah, basically. Um, you don't like pure one doesn't have limits, but then that's why it's said to be approaching one and not actually one. Yeah. So okay, yeah. Then moving on, these things are a bit important. I think some people tend to miss out on that. So first of all, the you need to know how to find the area of a region bound by a curve and the lines parallel to the axis. So okay, it's tweaking again. Let me just make a curve. Let's say you have something like this, and then you have a line going. Okay, no, that's a bit complex. If you have a line going like this, and they ask you to find out the area between this region, okay? So initially it seems a bit weird. Keep in mind that this is a sort of like a triangle, right? Right angle triangle. So what you can do is, whenever possible, use formulas of basic shapes. So you basically find out first of all the area under this entire curve, and then you subtract the area which is over here to get the shaded region. So usually what people remember it as is the integral of the upper function minus the lower function. So the curve over here is the upper function, and the lower function is basically this thing. Um, yeah, so what I would do for this is basically integrate the curve function or whatever it is. Okay, this is page right now. Anyway, from A to B, for example, okay, and then you just do minus the area of the triangle. So yeah, that's pretty much straightforward. Uh, since over here it has some extra area, if you were to do area like integration from A to B of curve minus the equation of line, that would be wrong because you're like considering this area as well, which you technically shouldn't. Um, okay, so that's for more simpler ones. Then you have volume of revolution uh, about one of the axes. So it can either be about the y-axis or it can be about the x-axis. Wait, so let me use this x square as an example. Y is equal to x square. So let's say this is 0, okay, and then this over here is 1, and they ask you to find out the total volume formed when this shaded region over here is rotated about the x-axis. So it's best if you try visualizing it a bit, but basically when you rotate it about the x-axis, you kind of end up getting a sort of a 3D shape which looks like this, okay? It's basically going to have these small cross-sectional areas which are circles, and you're basically summing up all those small cross-sectional areas to get um, the total volume. So as you can recall, the area of a cross-sectional circle is just pi r square, right? Now, in this case, because it's about the x-axis, it's just the radius is simply y in this case. So you just do integral from 0 to 1 of pi y square. That's how you'd go about it for this, which is somewhat easy, like a easy case. Now, the second case could be that they um, ask you to revolve this shaded region instead of like about the x-axis. In this case, it should be about the y-axis. So wait, let me just make the shaded region. Okay, and if you were to revolve it like this about the x-axis, so wait, let me. I don't know if I can make a proper shape for this. But basically, okay, wait, hold on. Yeah, this looks bad. But yeah, imagine that this is your x-axis, okay? The x-axis is going through the center of your circle over here. So the radius in this case is basically x, right? So you would do the same, but it's this time pi x square. Now your limits would have to change, okay? They would have to be the y coordinates. So this, because it, like I said, this thing over here is wait, hold on. Yeah, this is 1, and this point over here is also 1 because it's just y is equal to x square. So even in this case, it's from 0 to 1, and you just evaluate this, and this would be with respect to dx, this would be with respect to dy. Now this is like for simpler cases when you're just revolving it around the x or y axis. Uh, Apart from that, you could have a volume of revolution may involve a region not bounded by the x-axis of axis of rotation. Example: the region between 9 minus x squared and y is equal to 0 is rotated about the x-axis. So let me just make a rough sketch of that to give you an idea. So this is y is equal to 5, for example. Um, if you were to plot 9 minus x squared, so 9 minus x squared is, so you would have 9 over here. Um, it's basically concaving down, right? So something like this, okay? And then they say, for example, the region bounded between 9 minus x squared and y is equal to 5, okay? No P3 questions right now, Cham. Okay, and then they say that this shaded region is rotated about the x-axis. Now,
You can give question, yeah, sure.
okay, yeah,
I'll be
I guess. Okay, nerd. Um, so, right, if you were to visualize this, if so, basically you're revolving. Think of it as revolving this entire quadratic first of all. Okay, so if you do that, you end up getting, wait, so something like this sort of, okay, no, that's a bad example. It's hard to make the 3D shapes. Wait, um, yeah, this is so bad. Anyway, think about it as if you were to revolve 9 minus x square, okay, you'd end up getting something like this. If you were to revolve y is equal to 5 about the x-axis, um, you would get something which looks like this. Yeah, no, it's still bad, but I hope you guys get what I mean.
yes.
Yeah, anyway, so the total volume which you get by revolving the shaded region is the volume which is formed by 9 minus x square, this total volume, minus the total volume formed by y is equal to 5, okay, which is the reason why you basically do integral. And again, the radius in this case is just simply y, right? So you do integral of y1 squared minus y2 uh, y2 squared, and don't forget to add pi as well. So y1 in this case, it doesn't really matter which order it is. If you get a negative answer, you can just take the positive value. But yeah, um, that's pretty much it for this, I guess. Let me just stop sharing my screen. Give me a minute. Okay, yeah. So, um, that's it for the concepts. Now we'll move on to questions. Um, Wait, I'll just take a break of like a minute. Let me just see what's going on with my laptop because it's glitching for some reason. So give me like a minute.
Yeah, I'll try and explain the question teacher sent in chat till then.
Okay, yeah, that would be perfect.
Okay, yeah. So the first part, write down the equation. Like I know you asked for part C and D, but the equation of the equation of circle P is quite easy. You'll have x square plus y minus 2 whole square is equal to 100, and to the with coordinates 6 comma 10. Okay. But also show the second circle you need some to complete this establishing based on one. Alright, so for Q, we know the radius is 5 by 2 root 5, and so the r square part can be written as like just squaring that, so that would be what, 25 by 4 times 5, so 125 by 4. And so like the center is at the y-axis, so it would be uh answer. It would be what, x minus a square plus y square is equal to 125 by 4. And so you need to find the x part. So for that, you know the coordinates of a, and basically, one second. Wait, find the equation of the tangent. Okay, yeah. So in part B, you would have found the equation of the tangent to the circle P at A. So from that, you have the gradient of line A, or the line which is shown where A is there. And this line is going through the y-axis at a certain point. And this certain point is the center of circle Q. So once like you input y is equal to 0 into that equation of the tangent, and you'll get the center. You square the radius, and you'll get the equation of circle Q. And we need to verify that the y coordinates of both of the points of intersection of two circles are 11. Um, Wait, let me think how exactly should I explain this. Alright, yeah. So basically, it's a circle. So at two values of x, you'll get the same y value. And here you need to show that the point of intersection is the same. So you can just equate the two circles to each other, and or you could like substitute x or y into the other circle, and then you'll get an equation in terms of that, and it would be a quadratic, I would say. And you would get 2 points, and both the points would have y is equal to 11 and 2 points of x. Does that make sense?
Hey, are you guys talking about part 3?
Yeah.
Um, yeah, in this you could also just input y is equal to 0 like in both these equations, and you should end up getting the same form in terms of x for this.
Hmm. And so your part D, we have find the coordinates of the points of intersection of the tangent and circle Q. Hmm. Okay, yeah, so from part B and part C, we have derived the line A, the equation of line A, and the equation of the circle Q. Now we just equate them to each other, or again, we can substitute here, like we can substitute y is equal to whatever that value of whatever linear equation we have for line A into the y value for the circle Q, and then you would have a quadratic in terms of x. You get those, you'll get two values for x, and then you input those two values of x into the linear equation. You'll get two values of y. So those are the two coordinates, and to check it, yeah, you will get a quadratic for it. And yeah, to check if those values are matching, you can just input the x and y values into the circles equation, and it should give the r square value. Did that make sense?
Okay. Um, yeah, apart from that, I think someone also had this question.
Yeah,
Uh,
she only sent it.
oh, wait, should I go through this question
Yeah, yeah, sure.
though? Okay. Um, so over here you're given a circle. Okay, the center is 0, comma 0, and a straight line 2x minus 1 is passing through it, and it's intersecting at A and B. And then they're asking you to find the coordinates of A. So that's that. This part is pretty simple. You just uh, input this thing, 2x minus 1 over here. So you just get a quadratic, and yeah, it's pretty simple so far. So x squared plus 4x squared plus 1 minus 4x is 2. Um, then you get 5x squared minus 4x. Then you do 1 minus 2, so minus 1 is 0. Just use your calci. Keep in mind that you would consider the positive x coordinate because A has a positive x coordinate. Um, so you're getting x as 1, okay? X is 1, and then you can input x into this to get 2 minus 1, so 1. So 1 comma 1 is your answer for part A. Moving on, find the volume of revolution when the shaded region is rotated through 360 degrees about the x-axis. Give your answer in this form. Okay. So yeah, again, this is pretty simple. You're basically, because you're rotating it about the x-axis, your radius would be y. So your general form would be pi y squared, like I said. Um, so you can rearrange this to get 2 minus x squared. So this would be pi 2 minus x squared because that's equal to y squared. Now you have to think about the bounds. So it's going from this thing over here, which is 1, till the end of this, which is basically when wait, hold on, why am I freezing now? uh Wait, um yeah, basically when y is 0. Okay, oh my god. So x square is 2, and then you get x is root 2. So you just integrate this thing over here to get your volume of revolution. So pi from 1 to root 2 of 2 minus x squared dx. So just make sure you keep pi outside. Then this is 2x minus x cube over 3. Um, okay, yeah, sure, we could check it if we have time. Anyway, wait, so you can also use your calculator if you want to double check. I'll just do that to get the final answer. 1 root 2 and then 2 minus x squared. Oh, never mind, I'm getting a decimal. This part should be 0.21. Okay, so now you input uh, root 2 first. So 2 root 2. Oh my god, my handwriting is so bad. Minus, it was x cube over 3, right? So root 2 over 3. Wait, um, Legend, could you just check whether I'm doing everything properly or not? I might have.
Yes.
It's right. So, um, yeah, then you just simplify this form. I'm sorry, my laptop is like really slow. But yeah, you just simplify this form to get it in the one they have specified. And yeah, that should be it. Um, okay. Now then they're saying find an exact expression for the perimeter of the shaded region. So wait, let me scroll up again. So if you think about it, first of all, uh, this thing over here is, in a way, it's basically the arc length. Okay. Now finding out this length and then AD is pretty simple. The only challenging part could be finding out the arc length. So finding the arc length is, again, if you remember, it's pretty easy. OA and then OA is just the radius. Even this thing is the radius, and you just have to use a little bit of trig in this case. So um, wait, hold on. So D is basically 1 comma 0, right? So this thing over here, OD is basically the length 1, and then AD is the length 1. So if you were to find out theta, so that's just opposite over adjacent. So you just do tan theta is 1, and that gives you your theta value, right? So theta is pi by 4. And then you can use the formula arc length is theta r. And the radius is, in this case, root r. Just keep that in mind. Because it's in the form x square plus y square is r square. So s, or the arc length, is theta, which is, sorry, theta, which is pi by 4, times the radius, which is root r. But again, after this, you need to add two more values as well. So first of all, AD, which is 1, and then you also add this thing over here, which would be basically that would be 2. Wait, um, that would be root 2 minus 1. Yeah, why am I so slow, bro? Root 2 minus 1. This cancels out. You get root 2. Wait, let me scroll down. So you get root 2 plus root 2 times, oh my god, bad handwriting. And you can just factorize out root 2 if you want. So you get root 2 the whole times 1 plus pi by 4. Yeah, that's pretty much it for this. I hope you understood what I did. Um, Anything else?
I think the question which you had received before.
Oh yeah. Uh, you had received two questions, right?
Yeah.
Um, Wait, I'll do that on my whiteboard then. Uh, Give me like 2 minutes. Okay. Um, right. Let me just open the
All
whiteboard.
right. I'll explain geometric progressions till then. Do you want explanation for like finding the nth term, sum to infinity, or common difference, or like everything? The common difference. All right. So I'll just take the I. Okay. So let's see. Mm, The common difference is actually like if you get the first three terms, suppose your terms are 2, 4, and 8, your common difference is basically, one second, like I forgot how was it written, but it was you do the third term divided by the second term and second term divided by the first term, or the other way around. Basically, here, like if you take 2, 4, and 8, uh, or if you take 2, 4, 8, the common difference would be r is equal to 2, right? And if you do, like, you'll see that 8 by 4 is 2 and 4 by 2 is also 2. So it's just a way of confirming that. Both AP and GP and then
For APGP questions, I would just say that please just note down everything that you know so far.
so are you talking about the questions iron steel where they give like the first term of the arithmetic is this, and the geometric has the same term. The third term of the arithmetic is the same as the second term of the geometric, and the third term of the geometric is the same as the fifth term of the arithmetic. All right. Actually, it's like if anyone could send a question, it becomes easier to explain because otherwise, like I am trying to make up numbers in my mind, but like it's basically see you if they've given the first term of both of them are equal, so you have a is equal to a, and if you have the second term, sorry, yeah, third term of the arithmetic is equal to the second term of the geometric, so you would have a plus 2d is equal to ar, and then the third term of the geometric is equal to the fifth term of the arithmetic. So that would be a plus 4d is equal to ar square. Of course, they would have given you the first term or they would have given some information. So you use like you have a, you substitute a into if let's just assume a is equal to 3, then you have 3 plus 2d is equal to 3 times r. Yeah, send the question. So my thing with APGP is not so good. That's the only question I lost marks in.
Pain.
Of second term of a geometric and that too I lost 2 marks in show that question, bro. No, 1 mark. The second term of a geometric progression is 16 and sum to infinity is 100. Find the two possible values. All right, so the second term of the geometric is 16. So that means AR is equal to 16 and sum to infinity is 100. So you have A upon 1 minus R is equal to 100. So here we want to find A. So basically you put A is equal to 16 by R, and in the sum to infinity one, it becomes 16 by R upon 16 by R is equal to, wait, I'll write it. 16 by R is equal to 100 R. So like yeah, in the chat you'll see the working. So now you have a quadratic. You will find two values of R. Have they given anything specific of, okay, you have to find the two possible values. So you have two values of R which would give this sum to infinity of 100, and even the second term of 16, you just do 16 divided by that R value and you'll get A for two uh, the two possible values of A. Does that make sense? The find the common difference of the arithmetic and okay, yeah. Oh, nice. Some of the first term itself is 3. Okay, I'll explain it in chat itself. It's easy. So A plus 2D is equal to AR, and you have A plus 12D equal to A square. Now, R square. All right. Yeah. So this part is there, and so now you can take. Wait. Sorry. 1 second. Okay, so now here in that question, you can make 2D the subject as 2D is equal to 3R minus 3, and you substitute it into the second one as 3 plus 6 times 3R minus 3 is equal to 3R square. And this would give you a quadratic again in terms of R, and after you told it, uh, yeah, this would give you a quadratic. You solve the quadratic, you'll get two values of R, and then it's basically you just check, like you input both the values and you have to check which of the values is possible, and you input, and from that you get the common difference as well. Iron steel, does that make sense, or do you want like further working? This question I remember seeing. Yeah, sure. The iron steel, the stuff which I've written, does that make sense, or do you want me to start from the beginning? I remember this question which Homo has sent. I wrote it in the paper. Yep, I took the two equations and I equated them. I substituted d in terms of r. So I got this this equation, you'll see 3 plus 6 times 3r minus 3 is equal to 3r square. If you expand it, then it becomes a quadratic. And you solve the quadratic, you'll get two values of r. Then you substitute those values of r and get the values of d as well. And then you just check which is possible. I think that should only be one answer in this. It's possible there are two, but yeah, I think for the question Bomo is sent, the value of A was 7776. No, never mind. That's probably wrong. Oh yeah. Anyway, so you have the fourth and sixth term, 36 and 6. Both are powers of 6. Uh, so it's like quite visible. The difference of the terms is you divide it by root 6, and it's possible it's plus minus root 6, but they have told it's positive. So of course you take the difference. Sorry, r is equal to root 6, and from that you have r is equal to root 6. You have the fourth and sixth term. So like you have ar cube is equal to 36. From that, basically you just turn it around, you'll get a, the value of a, and then you have the sum to infinity. Okay, wait, I'll break it down one second. A r cube 6, a r 6. Um, how do I break it down? Basically, like, see, if you multiply 6 into 6, you get 36, right? And because here the values are reducing, there's a continuous division by something. And like if it was divided by 6, it would have been fourth term is 36, fifth term is 6. But that's not the case. So you would have the fifth term as 36 divided by something, and then the sixth term is 6. So the common difference would be root dividing by root 6. I I actually don't know if I can explain it in a simpler way. So yeah, so that's the common ratio, right? You have the common ratio of root 6. You have, see, just if you do 6 into root 6, you will have 6 root 6. If you multiply that again by root 6, you will have 6 root 6 into root 6, which is 36. And now in this case, we are going from 36 to 6, which means we have divided by root 6 twice. And that gave us the value of 6. So the common ratio, and since it's a root, it could have been dividing by negative or positives, because like it's the fourth and sixth term, so the negative would have gotten cancelled. But here they have clearly mentioned that the common ratio is positive. So the minus root 6, is there like a more specific, uh, like you could do, yeah, so see here you have AR cube is equal to 36, AR raised to 5 is equal to 6. You can divide it, so you would have R square is equal to, what is it? 1 by 6. R is equal to root 1 by 6, which is the same as dividing it, obviously. Yeah, DJ, that thing works when you have those terms. Here they've given the fourth and sixth terms, so you can just divide them. You'll be the A will be gone. It would just be one variable left, which is R. Yeah, so okay, yeah, so then I'll continue that. You have the common difference. From that, you can find A by making A the subject. So like AR cube is equal to 36. A is equal to 36 by R cube. You do 36 divided by R cube, you'll get A. And then the sum to infinity formula, which is A upon A by 1 minus R. So that would be, what's the value? 36, 200. I think A is what? 216 root 6. Yeah, it's 216 root 6. So your sum to infinity would be 216 root 6 upon 1 minus R, and R was 1 by root 6. So that would leave what? 216 root 6, 16 root divided by 1 minus 6, and that just become 1296 divided by root 6 minus 1. I think that is correct. If if you want proper working of it, just let me know. I'll access my paper and like I'll send a screenshot of my working itself because I have done this in the board paper. All right, Bomos is done. There is Gada, you want to solve that question right now, or should I do the question that was sent?
Um,
Like there are I think two questions left in chat. One by DJ and one by Zia.
yeah, if you want, you can do it as well. I don't mind.
All right, I'll just finish this time then because it's all the same topic. The
Yeah.
first term of a geometry, then first term, third term, fifth term. Given that all the terms are positive and not equal, find the sum of the first 20 in terms of A. All right. So you have the first terms are equal. The third term of the pro is equal to the second term of the arithmetic. So you have or Gardner, you explain that question till then. I'll do the working for this. So like since I'm typing it out.
Wait, which questions are not answered?
One is from one oh sorry, not from Zia, it's from Invisible Butterfly.
Uh, wait, whoever
I
has it, can they just resend it?
is and wait, Zia, did you change your name right now to Invisible Butterfly? What the yeah, yeah, I'll write on the board. Just question. What would it be?
Wait, hold on.
Also, no, wait. This is done. This is done.
Oh, this one is done. Wait,
Yeah, I
uh,
marked the ones which are left. I've put them in chat.
wait,
The
this one is question 4, right? The one DJ asked.
teacher has asked. Wait. Oh yeah. Wait. I think two people sent that question.
Oh,
Yeah, even Iron's team sent that.
okay, okay. So, what else?
Yeah. There's only one question left. Uh, which one? Uh, if you want to solve it, then go ahead.
Wait, let me just solve the remaining one.
Yes. Do you want? They wanted for the arithmetic progression.
Wait, can you guys see my screen?
Yep.
Okay. So they're telling you that the third term of wait, the third term of a GP is equal to the second term of the AP, right? So general form of a wait, hold on. Mm, Yes. Okay. General form of a GP is just um, A r raised to n minus 1, and then general form of an AP is just A plus n minus 1 d, right? Now they're saying the third term of the GP. So the third term would be AR squared, right? AR squared is equal to the second term of the AP. So when n is equal to 2, you just get A plus d. So this over here is your first equation. Okay. The second equation is that the fifth term of the GP. So fifth term is when n is 5. So a r raised to 4 is equal to the sixth term of the AP. Sixth term n is 6, so it's just a plus 5t. These are your two equations. Now, given that the terms are all positive and not all equal, so this indirectly tells you that um, D and R would be positive as well. Anyway, now they're asking you to find the sum of the first 20 terms of the arithmetic progression. So for an arithmetic progression, sum n is just half n, then 2a plus n minus 1 d. So for sum to 20, that's just 20 over 2, so 10 times 2a plus uh, 19t. Okay, you have to find out the value of this, and they're telling you that you have to find it in terms of a. Okay, so that means you need to find out d in terms of a first of all. So this is everything that you know so far, right? You can try. You have to basically eliminate r somehow. So for that you need to first of all take r like to one side. So this can be written as r squared is just a plus d the whole upon a, right? So one, wait, hold on, there is probably a better one. So what you can do is you can also divide um, the second equation by the first equation. Okay, so what that gives you is a r raised to 4 is a plus 5t, this sorry this upon this first equation, so ar squared, and then you have a plus t, right? So this thing, wait, I'll just do it here. So this gives you r squared is um, a plus hold on, a plus 5d over a plus t, right? Plus t. Now you can input this thing over here in terms of like back into r squared so that you can get an equation that's in terms of a and d. And then the logic is that you basically separate d and you'll get an equation in terms of a which you can substitute for d. So that's basically what I'm trying to do over here. So r squared we got as a plus 5d over a plus t. This is a plus t. This is a d. Okay, so we get a squared plus um, 5 dA is then it's just a plus d the whole squared. So a squared plus d squared plus 2 dA. Now a squared is cancelled. Okay, you can take everything to one side. So d squared and then 2dA minus 5dA. So minus 3dA is 0. You can divide d by 0 because d is equal to 0 is not a possible answer. So d minus 3a is 0, and then you get d as 3a. Let me know if I did it correctly so far. By the way. Anyway, after you get d as 3a, you just take this value substitution and you put it over here. So sum to 20 would be um, 10 times 2a plus 19 into 3a. Okay, and the final form that you get is 2 plus 19 into 3, that into 10. So I'm getting 590a. Let me just know if that's right. Invisible butterfly. Um, Creative Deco. Um, Anyway, apart from that, what else is left?
The form questions are left, but are the people who send those questions present in the session?
Yeah, invisible butterfly left. Oh, I just realized.
I think, wait, no, invisible butterfly didn't leave. Name is being changed.
Oh, okay. It's Zia now. Uh,
Yeah, yeah, exactly.
Wait, so uh, is your doubt clear now? Right, I swear to God, if you're trolling or something, I wanted to change the small one. Okay. Oh, alright. So that's solved. Apart from that, any doubts? I think we got two doubts in. Wait, let me just open the whiteboard. So we got these two as doubts in the Google Forms by some anonymous person. Anyway, this question over here got the new calci FX991CW. Yeah, that's allowed. I'm using that as well. In fact, that's actually much better, I feel. You can double check a lot of things. So use your
CW
calculator.
is which one?
It's the black
I
castle.
use, oh, that. Nah, EX is better, bro.
Bro, come on. CW is way better.
Nah, I've used both. I've used both.
Okay, fair.
And literally who the people who use CW want the people who have used CW want EX, but the production has been stopped. You can buy it on eBay for like 10K.
Oh, okay, man. Preferences. Um, um, Apart from this, there was, I think, one more question. Yeah, this one. Um, I mean, concept wise, this is pretty easy, but it is lengthy. So I'll just explain the concept real quick. The rest should be easy. So the equation of a circle is this, and then you have the line with equation y is equal to mx plus c, which passes through the point this. 0 comma 9, no, 0 comma minus 9, and it's a tangent to the circle. So find the two possible values of m, and then for each value of m, find the coordinates of the point at which the tangent touches the curve. Right. So you are basically finding out the intersection between the tangent and the equation of circle, and after you find out the equation of the intersection, you basically, because it's a tangent to the circle, so the discriminant of your equation of intersection is equal to 0. So keeping that in mind, you would solve this question over here, and you would end up getting two values for m, and based on that you get two different values for the point. Wait, hold on, you also have c, which is unknown. Equation of a circle is this. The line with equation this passes through the point this. Okay, yeah, so you just rewrite c in terms of m in that case. So you just do minus 9 is equal to c. Yeah, that gives you your coordinates. C is 9. So the two equations you have are x minus 3 the whole square uh, plus, hold on, that's not a y. Y squared is 18, and you have y is equal to mx plus 9. Sorry, it's minus 9. And yeah, you just input this, and like I said, the discriminant would be 0, and you just solve it like that. Yeah, that's pretty much it. Are there any other doubts? Um, which year was that question from? I'm not sure. If you want, I can send the question to you. You can uh, find it. Hold on. Okay, yeah, there's a question. Yeah, if no one else has doubts, then we can wrap up. Legend, do you want to add anything?
No, I have nothing. If anyone has some question, then sure. Otherwise, I think from our end, we're done. Also, like, if you have any questions and like after the session, feel free to ping us in the Pure Match channel. At least feel free to ping me, and I think Hydrogen
Yeah.
also wouldn't mind.
Yeah. Uh, Wait. Guardian inequalities. What keywords do we need to remember for? Wait. So, like greater than, less than, etc. Um. Wait. Which type of questions are you talking about? Like, I need some more context to be honest. But I think honestly, for pure one questions, they're like pretty straightforward in terms of inequalities at least. They'll, like you said, they would say this equation is greater than this thing or less than. Although again in GP or AP you get those annoying inequality questions sometimes. So just make sure you know the context properly, and just focus on the wording. Like there's nothing general. Like it varies from context to context. Oh, like those. Huh. So for that, um, I think I went through that like in the beginning. Okay. So wait. So just to add more context, are you talking about when a curve intersects a line or something, for example?
Well, I think I understood it. So yeah, the discriminant part, if they're asked, like, if you want, you put greater than when, if you like, I'll just consider the line here as the x-axis. So if you put greater than, you are looking for what part of the quadratic will give you a value greater than 0. So obviously, like most likely, you would have some part in the negative side of the x-axis. So you don't want that. So suppose it's negative from 2 to minus 2. Your answer when you put b square minus 4ac greater than 0 would be x less than minus 2 and x greater than 2. And if you want to find the negative side itself, you would put minus 2 to 2. And if you want to find when exactly is it 0, then you put b square minus 4ac is equal to 0, and that would give you the value of that when it is 0.
Yeah,
It touches the axis once.
yeah,
There
it,
are different uses of it.
yeah, and I just want to add on that, like when you equate a curve to a line or something, so that's just the equation of your intersection, right? So the solution to that equation is the number of intersections between the curve and the line. So when there is only one intersection, in that case the discriminant is equal to 0. If there's two or more intersections, then the discriminant would be, actually you can only have two intersections. So in that case the discriminant is greater than 0. And if there are no intersections between the line and the curve, then it's less than 0, basically. That's all. Uh, yeah, then that's pretty much it then. I guess we can wrap up now. Okay. Then thank you so much guys for staying till the end, by the way. Uh, yeah, that's it from my side then. Thank you for attending.
Very good from me. Bye bye, guys. Thank